Welcome back. Today we will be discussing the solution. We have seen this particular problem in the previous video where we have seen what is producer consumer problem, how is process synchronization being established using producer consumer problem, and what is the actual. This particular code is simply a code which is written in C language. You can write it in any language, but the meaning finally tends to be the same. So first, we will look into the solution for producer, then we will slowly go into the solution for consumer. On moving on to the solution for producer. As I have told you in the previous video, in the producer consumer problem, producer will be producing the items and he will be placing them in the buffer. When the producer produces the item and places in the buffer, immediately the consumer will consume the item. Now, as you can see, a do condition is written where empty and mutex are the two variables that are declared to keep the track of the buffer. Now, as we have known, semaphores perform two major operations, that is wait and signal. As we all know, when a wait operation is performed on a semaphore, the value of the semaphore gets decremented by 1, which means that value gets decreased by 1. Similarly, when a signal operation is performed on a semaphore, we all know that value is increased by 1. So, plus 1, I plus 1, value is incremented. Now, in the first part of the code, if you see, weight of empty, weight of mutex. Weight of empty is that this is an indication to the consumer that the particular consumer to consume the item from the buffer has to wait, because producer is producing something and he is placing it in the buffer. Now, while coming to the buffer, we have two statements, signal of mutex and signal of full. When producer produces an item, the value of empty is reduced by 1 because one slot will be filled now. So, as you have seen, weight of empty, as I have told you, value will be decremented by 1, so minus 1. The value of mutex is also reduced to prevent the consumer to access the buffer. So, this mutex is a variable which will act like a guard at the door. So, when wait operation is performed on mutex, which means that producer is already there in the buffer and he is producing and storing something. So, consumer does not have any right to enter into the buffer. Now, the value of mutex is also reduced to prevent the consumer to access the buffer. Now, the producer has placed the item and thus the value of full is increased by 1. Now, this particular signal, when signal operation is performed, the main functions of the semaphore are wait and signal. When signal operation is performed on this variable full, which means that it is an indication to the consumer that something has been added into the buffer, the consumer can come and consume the item that is placed in the buffer. The value of mutex is also increased by 1. The task of the producer has been completed and consumer has been accessed by buffer. In this previous part of the code, we have implemented wait operation on mutex, which means that it is an indication for the consumer that consumer has to wait. So again, when this wait operation is completed and signal operation is performed, it is an indication for the consumer that the producer had already produced something and had left the buffer. Now the buffer is available or accessible to the consumer. It is a signal. So this is the solution for producer, my dear friends. Now coming to the solution for consumer. As the consumer is removing an item from the buffer, the value of full is reduced by 1 and the value of mutex is also reduced by 1 by performing the wait operation, which means that wait of full. This statement means that this wait operation is being performed on the full variable. When a producer comes and starts producing something, he will see that a consumer is consuming from the buffer. So the producer has to wait until the consumer consumes the items in the buffer and leaves. So this wait of full will reduce the value of the semaphore by 1. taking it to a negative value, which means that they have the producer has to wait. Similarly, weight of mutex is the item that is placed in the buffer is being consumed. So this particular mutex and full will play a role. On coming to the signal operation, similarly, in signal operation, we can see that again signal operation is performed on mutex so that it is an indication for the producer that the consumer has consumed the item, the buffer is empty, now he can produce and place something in the buffer. Okay, and the value of mutex is also increased by 1 so that it is a signal for the producer that yes, now I can proceed, the buffer is empty, it is not accessed by anyone. So these are both the codes for producer and consumer. This is how the solution is being obtained, or synchronization of process is being taking place between the producer as well as consumer. Now moving on to the semaphores, we have mainly two types of semaphores: binary semaphore and counting semaphore. This I have already explained in previous lectures, but to remember, you are to brush you up with once again, these are the two types of semaphores that are available for us: binary semaphores and counting semaphores. Binary semaphores along with counting and counting semaphores. You read the definitions of these two semaphores, you can clearly understand what is the role of these semaphores, my dear friends. In the next upcoming video, we will be discussing the famous reader writer synchronization problem and the solution to that particular problem. Thank you.